Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the road to the chemists, but that's just peanuts to space.
Okay, I wanted to revisit the Fermi Paradox, which I've talked about before, mostly because I find it quite fascinating. So, the Fermi Paradox was postulated by Enrico Fermi back in the 50s, 60s, I think it was. Basically, he made the following assumptions. The universe is vast and old, with billions of galaxies and potentially billions of planets. The probability of life emerging on at least one of these planets is high. Some of these civilizations may have developed intelligent life and technology. Given the age of the universe, some of these civilizations should have had time to develop interstellar travel and communicate with us. The paradox is, despite extensive research, we've really found no conclusive evidence of extraterrestrial life or technology. So basically the paradox is, where the heck is everybody? Another scientist around the same time, astronomer and astrophysicist Frank Drake, thought about this and came up with the Drake equation in 1961, I believe it was. The equation is more of a thought experiment, so we don't really know a lot of the values to quote-unquote solve it. But even so, it gives a sense that there should be a number of advanced civilizations floating around out there. The Drake equation is a probabilistic formula used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. The equation is expressed as follows. N is the number of civilizations in the Milky Way galaxy with detectable electromagnetic emissions. So that would be the ones that we could find. So as you can see, there's a lot of these that we kind of don't know, but it gives you a framework to think about stuff. So as the quote at the beginning suggested, space is indeed big. A really starry sky seems vast, but all we're looking at is really just our immediate neighborhood. On a clear, starry night, most of us can see about 2,500 stars with the naked eye, which is roughly 100 millionth of the stars just in our own galaxy. And almost all of them are less than 1,000 light years away from us, or 1% of the diameter of the Milky Way, our galaxy. Also remember, the Milky Way galaxy is just one of a myriad of other galaxies out there. I mean, just in terms of the numbers, it's hard to believe that life did not start somewhere else. Currently, there are now more than 4,500 confirmed exoplanets that we have detected, with more being found every year. The sheer number of alien worlds again supports the thought that life may be plentiful throughout the cosmos. So, back to the Fermi Paradox. There's quite a few suggestions as to why this should be the case, that we're not detecting the life that we think is out there or should be out there. Here's a few of them, and I'll tell you my favorites at the end here. First one is the rare Earth hypothesis, where the thinking is that intelligent life may be extremely rare due to the unique conditions required for its development. The next one is the Great Filter. There may be some evolutionary or technological hurdle that most civilizations fail to overcome, preventing them from becoming detectable to us. Early arrival. We may be among the first intelligent civilizations to emerge in the universe, given the cosmic timescale. I find that one kind of hard to swallow, but hey. Communication limitations. The vast distances and limitations of light-speed communication may make it difficult for civilizations to detect each other. Self-destruction. Advanced civilizations may tend to destroy themselves before achieving interstellar capabilities, which kind of ties into the Great Filter. The zoo hypothesis. Extraterrestrial civilizations exist and may be aware of us, but choose not to make contact, observing us like in a cosmic zoo. Or we're one of the backwater civilizations that the other ones don't bother with. Different timescales. Civilizations may exist at different times, making simultaneous detection unlikely. So while simple forms of human society likely existed as far back as 300,000 years ago, more complex societies began to emerge around 13,000 years ago, with recognizable civilizations appearing about 5,500 years ago, which isn't long. That's a short period of time, considering the universe as we understand it is about 14 billion years old, roughly. The Earth is, about 4 billion years old? And only in the last 5,500 years have we had a recognizable civilization. And only in the last 100 years or so have we had any kind of technology that's capable of being detected from off planet. These last ones fall under the we don't know what we don't know sort of banner. Non-standard intelligence is another one. Alien life might exist in forms that we can't recognize or communicate with. It's just so weird and out there that we don't have any frame of reference. The simulation hypothesis, this has become a popular one recently, but who knows, you don't know, like I say, you don't know what you don't know. Our reality might be a simulation, explaining the absence of detectable alien life is, we're in a video game, basically. We're in Skyrim. The last one of the ones I have here is limited human perception. Our physical or technological limitations might just preclude us from being aware of other universes or dimensions and that kind of thing. My favorites of these, just thinking about it as logically as I can, I'm not a super logical person, but thinking about it in a more grounded way, I think the Great Filter is probably one where there's some limits that most civilizations fail to overcome. The other one that I like is the technological limitations, where interstellar travel or communication might be really, really difficult or even impossible. The different timescales one, I think, is the one that I gravitate towards mostly, just with the sheer amount of time that's passed since we believe the universe came into existence. Even if there are many societies developed and become technological, it's hard to believe they would all do that at the same time. And if the scattering is, thin enough and the time scales don't match up, it's kind of easy to see how we would sort of miss each other. So say it takes 1 million years for a civilization to be born, to flourish, and to finally die out or ascend to some other level. That's 1 million years. Think of how many blocks of 1 million years we've had just in the last couple of billion years. It's like ships in the night. We just pass each other and don't realize we're there. I think that, to me, seems like the most likely one. That and the Great Filter. What do you guys think? Has anybody thought about this? I mean, I find it fascinating. I would imagine we'll find something someday. It'll either be really weird or really mundane. Somebody will show up and they'll look pretty much like us, or something will show up and it won't be anything like us. It's fun to think about, though. So, as usual, links below. Thanks for watching and listening. If you have comments, feel free to comment. Feel free to subscribe. Click the like button, all that good stuff, and we'll see you next time. Bye.